Hello guys, and welcome back to my YouTube channel. In our previous video we write this code for selection sort in C++, and then we run this code and see a successful execution of selection sort. Now we will see the time and space complexity of selection sort algorithm. So the time complexity of selection sort algorithm is O(n) square, as there are two nested loops. One loop to select an element of array to be array one by one, so it has a time complexity of omega n, and then we run another loop which was actually the nested loop inside of our first loop to compare that element with every other array element, so it has a time complexity of omega n2. Therefore the overall time complexity for our selection sort algorithm will be omega n square, and space complexity will be omega 1, as the only extra memory used is for temporary variables while swapping two values in array. The selection sort never make more than omega n swaps and can be useful when memory write is a costly operation. So we have done our selection sort algorithm. Now we will see our bubble sort algorithm. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent element if they are in wrong order. This algorithm is not suitable for the large data set as its average and the worst time complexity is quite high. So it is recommended when we are working with smaller data set. So let's take a look how does the bubble sort actually works. So let's say we have this array of 5 integer having element in randomly sorting order 5, 1, 4, 2, 8. So let's see how this bubble sort will sort this unsorted array. So in the first pass, bubble sort start with every two elements, compare them to check which one is greater. So in our this array, first it will take these first two elements 5 and 1 and will check which one is greater. Here the algorithm compares the first two element and swap them, as 5 is greater, so it will come to right and 1 will come to the left. Then in the second swap it will take next two element and check. So as 5 is greater than 4 2, then it will again swap 5 with 4. Then it will take next two, which is 5 2. Now it will swap it also because 5 is greater, and then it will take last two. Now it will not swap because 8 is greater than 5. So that's what will happen in our first pass. Now for the second pass, it will again take these two elements and check it. Then it will go to the next two element, check if a swap is needed, then it will swap them, then our next two elements, and then again last two elements. So in our third pass the array is already sorted, but our algorithm doesn't know if it is completed, so the algorithm need one whole pass without any swap to know it is sorted. So it will try it again by first two, then second two, then third two, and then the last two. So now this time there is no swap involved, so our algorithm knows that our array is now sorted. So it take at least one no swap to know that array is sorted. So this is how our code will work. I have illustrated this. So first I will is equal to 0, and then j for I is equal to 0, it will do the j for the 6th time, and same goes for I is equal to 1, it will do it for 5 times, and then 4 times, and then it will do it 3 times, then 4 times, then 3 times, then 2 times, and then 1. So now we will take a look at code example, and we will implement this bubble sort algorithm in C++. So this is our code for selection sort algorithm. I will just simply delete it from here. Now it's time for the code of our selection bubble sort algorithm. So I will write our bubble sort function, void bubble sort. It will accept 2 parameter. First one will be the array, and second one will be the size of array. Now inside of it I will define 2 variable, I and j, for our loops. Now our parent loop I less than n minus 1, and then I plus plus. Now our child loop for j is equal to 0, and then j is less than n minus 1, and then j plus plus. Now inside of it we will check if jth index of our array is greater than jth plus 1 index. Then it will simply call the swap function, and it will pass the jth index of array and j plus 1 index of our array. Let's quickly type our swap function. yp is equal to our xp, and yp is equal to our temp. So after this swap function, let me type our print function. time for our main driver code. I will initialize an array of integer and give it value of 5 1 4 2 8, and then our size will be n. Now I will call our bubble sort algorithm which we just made and pass it our array and the size of our array. Now I will just print the sorted array. Now I will call our print function. So our code for bubble sort array is complete and ready to test. So let's test it out. Let me delete the previous compilation and run it again. So you can see our array is now sorted, but one thing you must have noted, that is it is taking more time as compared to our selection sort array. That's because it is doing too much comparison and swapping in each iteration. As we go back to our code, so we can see first we have this parent loop, and inside of this parent loop we have our child loop, which will run as many time as our parent loop, and so inside of it we are comparing the two elements. So in the first iteration we will compare first two element. In this case it will be the j and j plus 1, first and second index, and then if it is greater than the second one, then we will call the swap, and again now our j is 1, so now we are comparing first and second index. I just make this arrangement so you can see a clear picture of that. So yeah, at the first iteration we were at this, and then at the second iteration our j become 1 and our j plus 1 become 2, so it will compare these two, and after that our j will become 2, so it will be here, and j plus 1 will be this, and then it will compare these two, and after that our j will become this 0 1 2 and third index, and j plus 1 will be the last index, so it will compare that. And after the completion of this child loop, it will again go back to the parent loop, and this time our I will be the 1, so it will start the loop from this. So after the successful first iteration of our child loop, our parent loop will come into this second phase, and this sorting will be going on like this until all the elements are sorted in the array. So now let's check the time complexity and space complexity of bubble sort algorithm. So the time complexity of bubble sort algorithm is log n square, and space complexity is omega 1. So that's all from today's tutorial. Thanks for watching.